Hi, welcome back. In this session, we are discussing the types of pair of linear equations based on the analysis of their graph. So, here three examples is given. First one is x minus 2y is equal to 0, 3x plus 4y minus 20 is equal to 0. So, just analyze this. First, we need to find the ratio a1 by a2. What is a1 here? 1. 1 into x is x. So, 1 by 3. And here b1 by b2 minus 2y by 4. That is minus 2 by 4. Cancel, simplify it. You will get to minus 1 by 2. Now c1 by c2 is taken to this here c is 0 because there is no constant term. So 0 by minus 20 which is equal to 0. So comparing these two ratios, a1 by a2, we get a1 by a2 is not equal to b1 by b2. Okay, here a1 by a2 is 1 by 3 and b1 by b2 is 1 minus 1 by 2. Therefore, these two ratios are not equal. That is our interpretation. And if a1 by a2 is not equal to b1 by b2, then their graph will be intersecting lines. Intersecting lines. That means their graph will be like this. Intersect at one point. And what is the algebraic interpretation? That is, it has unique solution. It has unique solution. Because where is the intersecting point? That point will be the solution. That is, the point, intersecting point is the point in which common on both lines. Okay, so the corresponding value of x and y will be the solution. And it has only one intersecting point, therefore it has unique solution, one solution. It is very important to remember it. Now, take a second example. What is a1 by a2? 2 by 4, which is equal to, simplified, 1 by 2. Now, b1 by b2 is 3 by 6, which is equal to, again simplified, you will get a 1 by 2. Again take c1 by c2, that is minus 9 by minus 18, which is equal to 1 by 2. So here all the ratios are equal. a1 by a2 is equal to 1 by 2, b1 by b2 also 1 by 2, c1 by c2 also 1 by 2. So we can conclude a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That is our, after comparing the ratios, we got it. And its graph will be coincident. That means, suppose this is the graph of one equation, the another graph will be coinciding with the first equation. Okay, that means, what are the values or what are the points lie on this first line? All these points lie on the second line also. That means these two lines are coincident. And there will be infinitely many solutions, because what are the points on the first line, that will be on the second line also. That means infinitely many solutions we will get. Infinitely many solutions. That is our interpretation. Now, third condition is that here you can simply look at this pair. You just divide this equation by 2. What you will get? 2x plus 6y minus 9 only. That means ultimately these two equations are same. But just when we multiply one equation by another constant, any number, we will get a pair of linear equation with the infinitely many solution. So ultimately these two equations are same. That's why these two lines are coinciding. Clear? Now, x plus 2y. Now the third equation is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 is equal to 0. So first take the ratio a1 by a2, that is 1 by 2. 1 by 2. Here quotient is 1. And what is b1 by b2? 2 by 4, which also 1 by 2. So a1 by a2 is equal to b1 by b2. Now what is the condition in case of c1 by c2? That is minus 4 by minus 12, which is equal to minus cancelled 1 by 3. So here a1 by a2 is equal to b1 by b2, but which is not equal to c1 by c2. a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. So how it will be? The one is intersecting and the second one is coincident lines, and the third option is the only, that is parallel lines. Third option is parallel. In case of parallel lines, is there any common point? No, because these two lines never intersect, or it intersects at infinity only. So in reality there is no common point, that means it has no solution. It has no solution. So it is very important to remember this ratio. If a1 by a2 is not equal to b1 by b2, then it has intersecting lines and it has unique solution. And in case of a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then this pair of linear equation will have coincident lines and which have infinitely many solutions. And in these two cases, it has one solution, it has many solutions. So if the given pair of linear equation have solution, then these two equations are consistent. These two types of equations are consistent, and it has no solution, therefore it is inconsistent. It's very important. Every year there is one or two question asked from this, based on this concept. The types of linear equations. The question will be given like that: find the value of x or y or k or n if the given pair of linear equation is if the given pair of linear equation has a unique solution, or infinitely many solution, or no solution. Otherwise it will be asked if it has intersecting lines, or if it is constant, or if it is graph lines are parallel. So this condition you have to remember it, and these two are belonging to consistent category, and this is inconsistent because it has no solution. Let's take an example from NCERT. Exercise 3.2, question number 2. On comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following pairs of linear equations intersecting at a point are parallel or coincident. Okay, so I am taking option number 1. 5x minus 4y is equal to 0, and 7x plus 6y minus 9 is equal to 0. These are the two pair of linear equation given, and on comparing these ratios of coefficients, we just need to find whether it has intersecting or coincident or parallel lines. So first a1 by a2. a1 by a2 is 5 by 7. Now what is b1 by b2? b1 by b2 is equal to minus 4. But b1 is minus 4 and b2 is 6. Simplified, what we will get? Minus 2 by 3. Now here we can conclude that a1 by a2 is not equal to b1 by b2. Then no need to go for c1 by c2. We can conclude, since a1 by a2 is not equal to b1 by b2, it has intersecting lines, or it intersect at a point. Similarly, there are some other questions also given like that on comparing the ratios A1 by A2, B1 by B2, C1 by C2. Find which of the following equations are inconsistent or consistent. Find out which of the following equations have unique solution, exactly one solution. So these all questions are based on this concept. You can solve in the similar way. In the next session, we will discuss how to find the solution of a given pair of linear equation if it has exactly one solution. There are different methods we will learn in the next session. That's all.